Class 10, Chapter 8.4 Inorganic Chemistry. Hello students, this is your Archita ma'am. Today I am going to discuss in this presentation the preparation of ammonia, their properties, then hydrogen sulfide, then hydrogen chloride, sulfuric acid, nitric acid. So let's start the session. First is preparation of ammonia. Ammonia is prepared in a laboratory by heating ammonium chloride, ammonium sulfate with dry slaked lime or dry quicklime. Equation is given in the slide, you can see from there. The conditions required are the apparatus and chemicals should be perfectly dry. The reaction mixture should contain 1 part ammonium chloride and 3 parts slaked lime by weight. The reaction mixture first heated gently, then strongly. If we talk about the collection, ammonia is collected in gas jar by downward displacement of air. Drying of ammonia, if we talk, ammonia is dried by passing through the dry lime tower. Ammonia is basic, so only basic drying agent can be used. Acidic drying agents like concentrated H2SO4, P2O5, etc. cannot be used. Next we see properties of ammonia. Ammonia is colorless gas having strong pungent smell. It is lighter than air. It condenses to liquid at ordinary pressure at 33.4 degrees Celsius. It can be liquefied at 10 degrees Celsius applying 6 atmospheric pressure. Uses of ammonia is given in the slide. Ammonia is very important reagent for the manufacture of many substances. One of the example is it's a very important reagent in the manufacture of nitric acid. Differences of liquor ammonia and liquid ammonia. The concentrated aqueous solution of ammonia is called liquor ammonia. It contains 35% ammonia. The liquid ammonia is different from liquor ammonia. The former is liquefied ammonia, while the latter is a concentrated aqueous solution. Or simple terms we can say liquid ammonia is the condensed form of the gaseous ammonia. Let us check the chemical properties of ammonia. So chemical properties of ammonia includes basic property. Ammonia is a basic compound. It reacts with acid to form salt. Reducing property, equation is given in the slide. See the slide. When ammonia is passed over strongly heated black cupric oxide, the cupric oxide is reduced to red metallic copper. Thereby, ammonia is oxidized to nitrogen. Precipitation reaction. When ammonia solution is added to blue colored aqueous solution of copper sulfate, at first a bluish white precipitate of basic copper sulfate is formed. Then on addition of excess ammonia solution to this, a dark colored solution of a complex salt cuproammonium sulfate is formed. Which on dissociation gives copper hydroxide and ammonium sulfate. Nessler's reagent. Nessler's reagent is the alkaline solution of potassium mercuric iodide. In contact with traces of ammonia, a brown colored solution or precipitate is formed. This brown color or precipitate due to formation of basic amido mercuric iodide. We should take some precaution from ammonia. Ammonia is basic and highly soluble in water. It causes damage to eyes. Ammonia leakage may occur from ammonia reservoirs or ammonia tanks during transportation. In the laboratory or from cold storage, this may cause serious accidents. So, some precautions should be taken while handling ammonia. The face and eyes should be washed with large quantity of water. The face may be covered with wet thick cloth or towel and one should move to a safe place. Next we would see industrial preparation of ammonia. Ammonia is manufactured by Haber's process. The raw material N2 is obtained by fractional distillation of liquid air and hydrogen is obtained from water gas. So condition for the preparation of ammonia is temperature is required 550 degrees Celsius, pressure of 200 atmosphere, the catalyst iron powder in the presence of promoter like Al2O3 and K2O is required. At this condition, combination of N2 and H2 is an exothermic reversible reaction. Urea is produced from ammonia and carbon dioxide in two equilibrium reactions. Ammonia and carbon dioxide are reacting to give ammonium carbamate. Then it is undergoing a slow reaction to give urea. Hydrogen sulfide. Let us see hydrogen sulfide preparation required. Chemicals like ferrous sulfide, dilute hydrochloric acid or sulfuric acid. The main apparatus which is required for the preparation of the hydrogen sulfide is Gibbs apparatus. H2S is heavier than air, so it is collected by downward displacement of air. And for the drying of H2S, it is dried by passing through alumina or phosphorus pentoxide. Properties of H2S. H2S is a colorless poisonous gas with a smell like that of rotten egg. H2S is heavier than air. H2S is fairly soluble in water at 0 degrees Celsius and 1 atmospheric pressure. Aqueous solution of H2S is acidic. Aqueous solution turns blue litmus red. Chemical properties of H2S includes H2S is not a supporter of combustion but itself burns with blue flame. In insufficient air, it burns to give sulfur and water vapor. In excess air, it burns to give sulfur dioxide and water vapor. Acidic property. H2S behaves as a dibasic acid and produce normal salt and acid salt with alkalis. Like when it is reacting with sodium hydroxide, at first it is forming sodium hydrogen sulfide and the second time it is forming sodium sulfide. If we see the reducing property, when H2S is passed through orange colored acidified potassium dichromate solution, it is reduced to green colored chromic salt and itself is oxidized to sulfur. Equation is given in the slide. Next, when H2S is passed into the acidified aqueous solution of some salts, precipitates of metal sulfides with respective colors are formed. When copper sulfate is passed through H2S, it forms black colored copper sulfide. When lead nitrate is treated with H2S, it forms black colored lead sulfide. Similarly, when silver salt is treated, it forms black colored silver sulfide. With zinc also it reacts and forms black colored zinc sulfide. Preparation of nitrogen. On heating, aqueous solution of ammonium nitrite, nitrogen is produced. But this decomposition of ammonium nitrite is very weak and there is a chance of explosion. If ammonium nitrite is heated alone to reduce the speed of this reaction, a mixture of aqueous solution of sodium nitrite and ammonium chloride is heated to prepare nitrogen. At first, ammonium nitrite is produced by the reaction between sodium nitrite and ammonium chloride. So instead of using ammonium nitrite directly, an aqueous mixture of NaNO2 and NH4Cl are heated to produce N2. Now let us discuss properties of nitrogen. Physical property, if we discuss, at ordinary temperature and pressure, nitrogen is a colorless, odorless, tasteless gas. It is slightly lighter than air and slightly soluble in water. Then chemical properties of nitrogen. The N2 molecule is very stable and to some extent inert. Because atoms take part in chemical reaction, the nitrogen atoms in N2 molecule are bonded by triple covalent bond. So bond dissociation energy is very high to break the N2 molecules into atoms. That is why N2 is comparatively unreactive. One of the important reaction is with calcium carbide. When calcium carbide is heated in nitrogen at about 1000 degrees Celsius, calcium cyanamide is produced along with separation of carbon. The black mixture of calcium cyanamide and carbon is commercially known as nitrolim. It is largely used as fertilizer. Hydrochloric acid. There are various methods for the preparation of this hydrochloric acid. First, if we see, it could be prepared by the reaction of the hydrogen and chlorine, or it could be prepared by passing sodium chloride in sulfuric acid. The first method which is given, it's called synthetic process. There is no such name for the second method, just simple reaction. Sulfuric acid. Sulfuric acid is prepared by contact process. Why this process is called contact process? In the second step, we would see sulfur dioxide is converted to sulfur trioxide in contact with vanadium oxide or platinum catalyst. That's why the preparation of sulfuric acid is termed as contact process. Now nitric acid is prepared by the method called Oswald process. Manufacture of nitric acid is done by Oswald process.